Welcome to Biology My Passion. I am Soumya Harikrishna. We are going to do revision of the chapter Magnetic Effect of Electric Current. The entire chapters of class 10 are available in my channel Biology My Passion. If you can visit the channel and go to the playlist, there you type the name of the chapter will be available. Apart from that, lot of extra questions have been uploaded. You can type questions class 10 or extra questions. You will come across the extra questions which includes previous year questions, important concept based questions, competency based questions, and also numericals in physics. So let's go for the concept based questions, very important concept level questions in this chapter. In the coming parts we will do the question practices. So the first question is define magnetic field. So magnetic field is the space around a magnet in which the force of the magnet can be detected. Is magnetic field a scalar or vector quantity? You know, magnetic field is a vector quantity, means it has both direction as well as magnitude. What are the properties of magnetic field lines? This is a very important question. Magnetic field lines are imaginary. We are assuming these lines, but they are not really there. Magnetic field lines form closed loops. No two magnetic field lines can intersect each other. That is another reasoning question. Why no two magnetic field lines can intersect? Because if they both are intersecting means what? At that point, the compass needle should point to directions, north directions, but that is impossible. Tangent drawn at any point on the magnetic field curve gives the direction of the magnetic field. Strength of the magnetic field of a magnet is shown by the closeness of the magnetic field lines. We know that when they are near the magnet, they are very close circles. When they go away from the magnet, the circle will be increasing in radius. And also near the poles, they are crowded in the case of bar magnets. Rule to find the direction of magnetic field around the current carrying conductor. Right hand thumb rule can be used, or Maxwell's corkscrew rule can be also used. What are the factors on which the strength of the magnetic field around a current carrying conductor depend? The strength of the magnetic field is directly proportional to the current passing through the conductor, and the strength of the magnetic field is inversely proportional to the distance from the conductor. That means if you increase the current, the magnetic field strength also will increase, but if you increase the distance from the conductor, then the magnetic field strength will decrease. What are the factors on which the strength of the magnetic field around a current carrying circular loop depend? The second type of current carrying conductor we are learning is the circular one. Here also the 2 points are the same. That is directly proportional to the amount of the current flowing through the loop. That is the directly proportional current like the previous case, and also it is directly proportional to the number of turns in the circular loop. The more the number of turns, the more strength we can experience, and inversely proportional to the radius of the loop. That means again when we make huge loops, actually the strength will be less. What is a solenoid? Solenoid is a coil of closely wound insulated copper wire in the shape of a cylindrical tube having diameter lesser than its length. We know that when it is conducting electricity, it acts like a bar magnet. What are the factors on which the strength of the magnetic field of a current carrying solenoid depend? Here also, like the previous cases, directly proportional to the current in the solenoid. So if the current increases, the strength also will increase. If the current decreases, the magnetic field strength decreases. Also directly proportional to the number of turns in the coil. By increasing the number of turns, we can increase the magnetic field strength. It also depends on the type of the material of the core. So we can see the use for which we are making it. Depending on that, we can change the type of the material. Differentiate between electromagnet and a permanent magnet. You know, electromagnet shows temporary magnetism only, whereas permanent magnets have permanent magnetism. Polarity can be changed by reversing the direction of the current. So we can change the direction north pole and the south pole by changing the current passing through it, but in a permanent magnet it cannot be changed. In the case of an electromagnet, we can increase or decrease the strength of the magnet by either changing the current passing through it or increasing or decreasing the number of coils around, but permanent magnet we cannot change the strength. In an electromagnet, it can be demagnetized by switching off the current easily, whereas it's not that easy in the case of permanent magnet. Electromagnet can produce a very strong magnetic field because we can change the factors affecting it, whereas permanent magnet cannot produce a strong magnetic field. Electromagnet is a solenoid with a soft iron core, whereas permanent magnet is made up of steel. What are the factors on which force on a current carrying conductor placed in a magnetic field depend? We know that whenever there is a current carrying conductor in a magnetic field, it experiences a force. So that force is directly depending on the strength of the magnetic field. It is directly depending on the strength of the current also, and also it directly depends on the length of the conductor. So by increasing the magnetic field strength, or by increasing the current, or by increasing the length of the conductor, we can increase the force. What are the frequencies of DC and AC? You know, DC is direct current, AC is a alternating current. We know DC does not change its direction, whereas AC is changing its direction. So frequency of a steady DC is 0. Whereas frequency of AC current in India is 50 cycles per second, so we call it as 50 Hertz. What are the advantages of AC over DC? You know, AC is always preferable compared to DC because AC can be transmitted at very high voltage and lesser current over long distances with a negligible loss of energy. Any voltage can be obtained by using stepping up or stepping down the transformers. We can change the voltage, and also it's highly efficient and also can be easily converted to DC. Identify the two safety measures used in electric circuits. We know it's dangerous to deal with electricity. So we have two measures basically. One is fuse or the circuit breaker, and the second one is earthing or grounding. Fuse or circuit breakers, when overloading or short circuiting happens, the current in the circuit becomes much more than the rated current. This blows the fuse or trips the circuit breaker. Whereas earthing or grounding is connecting a metallic body of an electrical appliance to the earth with the help of a conductor. So instead of passing through our body or getting electric shock, it will pass to the earth, so we are protected in this case. So any of these concepts, if you feel you need more clarification, please go to the channel and watch that part of the video explanation, then come back to this questions. So in the next question, we will see more application level questions. So if you find it helpful, please like